Hello everyone. Today's our topic is radioactivity. So what's radioactivity? This is a process where the nucleus tries to attain stability by emission of either alpha or beta particle or the gamma rays. Well, radioactivity is basically a statistical process and it is probabilistic. It's not necessarily that it will always occur. So it is not deterministic. At any given time t, at given time t, nb the number of nuclei left to decay, nuclei left to decay. So the decaying rule says that the rate of decaying is directly proportional to the number of radioactive nuclei left. Okay, so we take lambda as the constant of proportionality, constant of proportionality. So dn dt equals to minus lambda n. On simplifying, it becomes dn by n equals to minus lambda dt. So when we integrate it, it becomes ln n equals to minus lambda t plus k. At t equals to t0, that's basically the starting of the reaction, n equals to n naught, that's the original number of radioactive nuclei. Therefore, we put a 0, so we get k equals to ln n naught. So k equals to ln n naught. Therefore, ln n by n naught equals to minus lambda t, or n equals to n naught e to the power minus lambda t. Always remember, this n is the undecayed nuclei. Undecayed nuclei. Therefore, when we plot this, as you see, this is an exponential equation. So when we plot this with time nuclei, it basically goes on reducing like this exponentially. And at certain point of time, the number of nuclei undecayed will be equal to half of the number of nuclei present. So at t, where half is present, there n equals to n naught by 2, or n naught by 2 equals to n naught equals to e to the power into e to the power minus lambda t, or 2 equals to e to the power lambda t, or lambda t equals to ln 2. This is the half. We're considering half, or t half equals to 0.693 by lambda. This is called half-life. In general, number of radioactive nuclei left after n half-life is determined by this empirical equation. N naught into 1 by 2 to the power n. So basically, after each half-life, first it was suppose 10, then it becomes one half-life 5, then another half-life it becomes 5 by 2, then it becomes 5 by 4, and it keeps on going. So basically, that's the way. Now we are going to discuss the average or mean life. So the average life is found to be the sum of times of existence of all the atoms divided by the initial number. So if we consider n to be a very large number and we approximate the sum is an equivalent integral, we find the average life as, well, average life is determined by tau. So we get tau equals to sum of time of existence of all nuclei. Sum of time of existence, so t equals to t to infinity of all nuclei divided by initial number of nuclei. And that comes to be 1 by n naught integration t to infinity. So dn equals to, we know that dn by n, uh, dn by n is directly proportional equals to lambda t. Therefore we get it here like t n lambda dt, because we're considering dn, a small part here, divided by, we're taking the n naught inside, and n equals to n naught e to the power minus lambda t. So it basically turns like this: tau equals to integration t to infinity lambda t n naught e to the power minus lambda t by n naught dt. So n naught and naught cancels out, and it becomes lambda is a constant, as is a constant of proportionality, integration t to infinity t e to the power minus lambda t dt. So this turns out to be, this turns out to be integration, we get it's 1 by lambda. So basically average life is 1 by lambda, and lambda equals to 0.693 by t half. So tau equals to t half by 0.693, or average life equals to 1.141 into tau half. Alternatively, we can also do this. Lambda is basically the probability of decay. This is a decay constant, and tau is the average life, so it's the probability to live. Probability to live. Therefore, according to mathematics, lambda into tau equals to 1, or 0.693 by t half equals to 1 by tau, or tau equals to 1.141 into t half. Thank you everyone. Please like, share and subscribe.